Welcome everyone to this tutorial where I would try to explain how a breadboard works and how to read a circuit that is embedded on a breadboard and how to translate it into its schematic diagram. In particular, for this particular video, we are going to talk about capacitors in circuits, and maybe there would be another video wherein we will be dealing with resistors in a circuit. So before that, let's try to have an idea or to introduce this particular device known as your breadboard. So as you can see, a breadboard, uh, the reason why it's called a breadboard is because it is a board that looks like a flat piece of bread, and there are a lot of holes, which is kind of reminiscent to some of the types of bread or biscuits that we eat most of the time. Now, in electronics, the breadboard is one of the powerful tools in making a circuit because it eliminates the need for a lot of wires and it makes connections easier to understand. So, in particular for this breadboard, we see a lot of lines. Okay, so at the top, this is the positive terminal of your battery for this specific type of a breadboard. And the bottom part is the negative terminal of the dry cell. So that means if you're going to make a circuit using this breadboard, you just connect the wires on the top and on the bottom so that it would ensure that it would be a closed circuit. Now, how a breadboard works is that some of these holes are actually connected automatically to one another based on how they are made. So for instance, for the holes that are on top, okay, they are all connected horizontally, like this one, right? So that means all of the holes on the top are connected horizontally with each other. So if, let's say you made a connection to the leftmost hole, then it would be connected to any of the other holes along the horizontal. So like what I said, the reason why we use breadboards is because it lessens the need for additional wires, because you just insert some wires on these holes and they would automatically be connected with each other. Now for the holes in the middle, they are connected vertically. So for example, for the first column, all of these are connected vertically. The same thing with the next one, the same thing with the next one, and so on and so forth. So you basically get the idea, right? So the reason why we need to know that is because if we're going to interpret a certain circuit, we need to make sure that we understand how all of these holes are connected for analysis. Now, to make it more clearer, let's try to look at this particular circuit, okay, which consists of 9 capacitors. Now, as you can see, in those 9 capacitors, all of them have a value of 100 picofarads, but we don't really need to be concerned about the capacitance of each capacitor. We just want to know how we can translate this from a circuit on a breadboard to the schematic diagram. So in this case, let's begin our schematic diagram the with the terminals. Okay. Specifically, the positive terminal is at the top and the negative terminal is at the bottom. So we make our schematic diagram like this. Okay, so the plus and minus signs are not really needed, but since the symbol for capacitors and dry cells are a bit similar, I guess it would be better if I put positive and negative symbols to denote that we are talking about the dry cell with this one. Right, so this is what we do next. So notice that for the next part, notice that the battery is connected to this immediate capacitor. Okay, so we call this C1. And if I'm going to draw that in the schematic diagram, I can draw it like this. Okay, and then notice that this C1 is connected to 2 points. A green wire that goes right there and another capacitor. So for this particular capacitor, let's try to label that as C2. Okay, so this is C2. Now notice that here, it's kind of like a junction. Okay, or an intersection between 2 points. So this junction is actually this one. Okay, which means that is where the connection splits off. Okay, which is something that we would try to tackle later. Right now, let's try to look at the capacitors that are connected in series in a way to C1. So this is C2, and if you try to look at this particular circuit, this capacitor is then connected to another one on the other side, and we'll label this as C3. So this is C3. And then this one is connected to this one, and let's say that this is C4. And notice that C4 is then connected to the negative terminal. So it all goes back to the dry cell. Now, how about the junction? So if we try to continue connecting this one, okay, particular this wire, we would encounter a connection to another capacitor, which we can label as C number 5. So I can draw another capacitor here and label it as C5. And then notice that this capacitor is again connected to two connections. Okay, another capacitor and another wire, which again would be another junction. Okay, which is something that we would be dealing with later. So let's look at the capacitors first. So as I go down, this will be C6. This will be the junction that I was talking about earlier. And this will be C6. And then if we try to imagine the holes again, this will be connected, and then there's another wire that gets connected to another capacitor, which we can label to be C7. And notice that C7 gets connected back to C4. So it makes sense that C4 and C7 is kind of like a junction as well, or they meet another junction. Now finally, for the second junction, we try to analyze where it goes, and we encounter another capacitor. We call this C8. And then C8 is in series with another capacitor, which we label to be C9. And notice that C9 would then be connected again to C7, which means this is another junction where they would meet. And doing that, we are able to translate this particular circuit on a breadboard into a schematic diagram. So hopefully you find that helpful, and thank you for watching.